Hello, this is Lazarus Wong from Hong Kong, and I'm AWS Hero, Microsoft MVP, and Google Developer Expert. But today I would like to share a talk about the object-oriented programming in Python. I'm not talking about cloud technology this time. And okay, first of all, I think every student or everyone should know all programming in depth, as you need to have this kind of concept for all kind of IT setup. But probably you are really very difficult to understand the keyword so-called encapsulation, polymorphism, inheritance, and data abstraction, the four main concept. But don't worry about it. At this moment, you will not understand. But after this section, you will have some very easy understanding. It is really real life object or interaction behavior. Just something like human, not about something dev or something programming or technology. Yeah, you can think it very human-like. Um, okay. First of all, we need to think about this is a kind of modeling. You try to describe something, use the programming language to describe the real route, the behavior, the properties, what kind of things, and this is just compose your software, your program with a lot of small pieces, so-called classes. In the real world, you will always use a bread to put everything inside, and then you try to bring your bread to your school, everywhere, and logically, you just put many items inside a bag, and then for the bread, not like some toll bag, you get a lot of small pockets, small area to put different size things there. For example, this is mobile phone, this is the iPad, and then you just try to carry your bread from one place to other, from school to home, from home to school, and then if you want to give something to your friend, you just put everything in the bag and then pass the bag to other people. This is the logic in the real world. But now we are want to apply this kind of thinking to the programming methodology. Yeah. First of all, I want to make use of something like a game style examples of showcase for to let you understand why we need to design something is like a bad to connect something in a collection. And this is like that. For example, you got a Street Fighter. Okay, Street Fighter. Yeah, maybe King of Fighter. Okay, we are thinking about King of Fighter. And then you will, first of all, you need to describe this scenario. Take a look. There is two stick fighter. Okay, so-called stick fighter. And then you need to have a name of the fighter. So-called Ron, so-called Ken, and then you get a HP, so then you have the life in your game. How can you model this in your program? Is the arc. We, okay, very similar. And instead of we call it a bad, actually for the programming for computer, you need to consider that it is you got a memory, you got a RAM, you got a hard drive, whatever. It's so-called memory. Memory is just write down something, okay. But the style of writing is a 0101, not just you are writing on a paper. You got a paper and then you write something there. It's not this side, but it's very similar. You will put your data as a object, something like that, and then every object you get many field. Here's the field, okay, different size, okay, your different size log, and then it is so-called the log size. We will consider is it a type, and then hold the data of your program together, and then you pass a bed to one side to other, or to modify the data grouped together in a bag. This is the idea of classes. Okay, here's the example. How can we model a Street Fighter or Stick Fighter here? You just have a fighter here, and then we mentioned that every fighter should have a name, should have a HP, so that it have a life there. Oh, you want to model the scenario we mentioned before. You got two fighter, Ken and Ron, and then you just put the name fighter Ken 100. 100 is the HP, and then Ron 100 is HP, and then you can try to access or modify the data inside a class, just like a bed. You got a bed, two, you just got two things inside. You got your first classes in Python. It's quite straightforward. The thinking of classes is the first idea is that you group the data together with different type in different size. Okay. Oh, what is the relationship between the object and classes? And it's very, very important. You need to think about class. You need to make it clear. You will need to have something like making a cake. Okay, you're making a cake. You need a template. Okay, you put a template. This is one of the template, and then you put the put the egg, put something there, put it in the template, and then prop, you copy run, copy a do the action, copy. Yeah, you think about the classes is a template, something very similar about the like a template here, but the memory is the contact. Okay, if the food, okay, it's an ingredient. Okay, you just make a copy, and the idea is that every time you leave something through a classes, you create a object. A object just something with simple idea is that you group the memory together in a well structure. Okay, you got different slot, physical sizes. And then later we will talk more about classes, not just like that. The objects, not just like that. We can also model the behavior. Okay, just make a mooncake. You need a template. Yeah, the Chinese mooncake. Yeah. Oh, okay. For object data modeling, we are talking about data modeling. In a lot of cases, we don't want the program or something is illogical or not making sense. For example, you make a fighter can without putting any parameter there. Okay, you don't have argument, you don't have parameter. You don't tell the energy how much HP it has. You will got the problem. If this program really able to run, you will got the logical one-time error during your run. Since you're fighting with someone, no name, no HP, how can they fight? So, it is something so-called we call required field on mandate. You must input it. How can a program designer to ensure that something you create a program, create a classes, create object, it had the name and HP? It's quite straightforward. We just do the source code previously. We so-called something using something writing the pattern so-called constructor. You must present your name and HP here. If you run this program, you will got an error. We solve the problem. If we just write a classes and then just a very simple source code like this one is a template. Then you input the write the style code here. You will always ensure that a writer will always have a name and an energy and HP. And also, we don't want to have the chance for the user to reset some value or input some invalid value into the program. For example, when you're writing a fighter model the fighter, you don't want the fighter suddenly rename himself to triple X, and also to put their net energy from 100 Earth to -1. It will be crazy your program. How can we solve this kind of problem? We don't want our user to train it anytime. We want to have some logic. Read only. First logic is read only. Name will be read only. For energy, we'll have logic. No negative energy. Only 0 to 100. How can we make sure the data is always correct or valid? And the logic is quite easy if you're using the object-oriented programming method to create a classes. For example, here is the examples code. You just in the class directly here, but you can set up something called properties. Okay, properties. But this kind of coding style is a classical one here. If you using the latest version of Python, there is something called data classes. It's very similar. But I just try to show the classical coding style for you. You just want to understand that you better use a classical style to understand the design. Well, quite straightforward. You just name here, but you double hyphen. Okay, double hyphen name, double hyphen HP. For double hyphen, we will from convention we will show that you will not be able you are not allowed to modify it directly from the program. Program is supposed don't allow to modify it. You just have this kind when you want to get a name. add the property here. This is property. Get an M, call get an M, you return an M. Get an energy, return energy. However, when you want to set your energy, this is so getter, this is setter. Setter, it means you set it up, set the new value. You set the new value for the HP. We will always have the sum logic here. For example, negative value, you got a very punch and a negative value, and the negative value becomes 0. Positive value just directly handle it. If this logic, you write the program here, you will not have the problem of renaming can. Since there is no more setter for the name, you can't rename the can into triple X. It will not work anymore, and you will got an error. And also for negative energy, you can't set the name. You get the negative energy will become 0. It solves a lot of problem. Since we just use the cars and then very simple logic, so-called access control. You have access control. You have the access control to read something, access control with something, and access control to write something. You can have the full control of your data to make it always correct. And also, instead of sometimes the logic is wrong, may not be good. Yeah, we just so-called eat up. You just take the error since it's something someone may hack you. Okay, instead of just correct the data, you think is it not logical? You can do something like that. For example, oh, I just write an error, stop the program. Okay, we will learn more about you was learning the Python programming before. You know something called exception handling. We just write an exception, so attribute exception. This attribute invalid if something negative 0 or 100. Someone may hack your program. I don't want my program to handle here. I want to lock it or stop it. So we write the error. Or other case, we just let the error in. So we can always have the control of what happening. Since maybe you found something very illogical, we don't want to change it to 0 or 100. We just give it an error. For other kind of access control, sometimes in Python by built-in there is no as compiler handling to block people to access the data. But by convention, we will sometimes say, oh, we will have the private class and public. Private, I mean something very secret. I don't want other to use it. I don't want someone to touch it. This is private. For public, everyone can touch it, can read it, can use it. For something underscore, double underscore as a prefix, you are supposed not able to call it here. But but not allowed. You do not need to call. You can't call it. But from compiler point of view, with the Python, you can still double underscore to call it. But this is for the developer. The convention, we will not call anything start with two underscore. This is something in Python. But for other programming language, if you mark private, you will got error in general. Okay, now let's have some recap. We have solved two problems. We can have the default value always ensure mandatory required value. For example, the name HP for a fighter. Just your constructor. You can have the read-only view or validation of the data, tracking your data through the getter and setter. But if you want to make something read-only, it's very, very common in the IT world. So, for example, you load something from database, the email address and username will never be allowed to be changed. How can you model your Python to store something represent in your database? Primary key is not allowed to change. You just create a constructor and then remove the setter. Just give the getter with the reader, getter for reading. You can solve the problem. Okay. For example, you have a constructor here. It's still not very good. Okay. Since this is not already makes sense to ask your user or classes with the data they input themselves. For example, the energy, they can input any number of energy. Or for example, I just want to everyone have a default value. Some super boss may have more power, more energy, more HP. And you do want to let them set it, but don't want everyone set it. Is this not making sense? How can we model the data with the default value? It's quite straightforward. This is something built in Python. You can do something like that. If you remove it, okay, you just remove from constructor. You are not able to set it. This is one of the solution. Everyone got 100. But if you still want to have some super boss have more energy. You can use other right thing, some default value, default argument to handle it. And okay, for default 100, but you hope to let the super boss have more energy. How can you do it? This will be allowed that not like previous slide. Previous slide is not allowed that you can't input it. If you remove it, you can't input it. But if you want to let them to set more energy, in the case, you can do something like this. Let's set up the still keep the parameter in the argument. Okay, keep the parameter here over the argument of constructor, but you have the syntax like that. The default value equal 100. If you don't mention it, it is 100. If you mention it, you can set other value. But potentially, you should have some validation logic. Okay, since you set the HP, maybe someone put negative 100, but we just ignore this logic here. Okay, and this is you have just learned that something very complicated and everyone don't understand. It's so-called encapsulation. Just very actually very simple. You just learn encapsulation. Encapsulation is that you have some data, okay, inside a class. You want to have some privacy, use some access control. Not everyone can touch it, can change it, can read it, can write it. Even though you can touch it, you can have some logic. This is encapsulate. Yeah, encapsulate mean you close up, encapsulate something. You have a bed here, encapsulate something. Yeah, and prevent the code from the data being randomly accessed is very important, since you need to make sure your data correct, your program will be correct. And the ability to modify our implementation of source code without big data, since you hide the setter, you don't need to show the detail to outside. People don't know. It is something good. We will know more later. Don't let people to to see too much information. Is something nice. And encapsulation give you the maintainability and flexibility extensibility, since you can train your logic, train your implementation straightforward. Since others don't touch it, they will not depend on your hidden implementation. Okay. This is something in Chinese, but never mind. I just explain in English. Logically, everyone in the world, you have a car. You know, in industry, you see a lot of girls they driving a car, okay, driving a motorbike. Everyone able to know that you step on the gas, it will faster. Step on the brake, it will stop. That's all. Okay, this is very important. You don't need to know too much. If you need to know the detail of the engineering, how to operate, how to something, most of the people will not be able to drive the car, since it's a very not everyone is engineer. So logically, it is quite straightforward. You try to encapsulate the detail. Don't let others know too much. You just tell people, you step on the brake, stop. You step on the gas, it's faster. That's all. And you know, just show them the unnecessary, hide the unnecessary detail, and then show explore the very simple API to them. Application programming interface, very easy to use. Function call, then simple is beautiful, and then you will become, since people don't touch the detail, they will not make error because of they change the detail. It's make your software quality higher and easy maintain, more easy to extend. From Chinese, this is quite straightforward. You just draw something, but don't draw the organ inside. You draw a human, but you will not draw the internal organs. This is so-called information information hiding. You just hide the information. Don't show too much detail to others. This is something beautiful. You draw a beautiful woman, beautiful girl, but you don't draw their internal organ. Okay? Now we have something extend extra activity. For example, we want to model the fighter, the behavior. They go forward. Okay, he move forward, and then I can kick the operand, and then the operand will move backward. Yeah, the logic is that someone rock in, kick it, and and then it moves. Yeah. How can we model the behavior? Now it's continuous. Um, you need to think about something not just like a bat anymore. It's something like a a a organ, a something living thing, animal or a robot, whatever it is able to do something. Yeah, you want to do something. For example, for this case, what they need to do, you need to think about your use case. This is the modern technique. You need to think about the fighter here. The fighter should be able to rock. Okay, they can rock. One of the fighter can rock toward another fighter, and then kick it. Okay, the two action fighter supposed need to able to do to model the previous scenario. Okay, and but you need to think about it when you take some action. You need to think about what kind of information or data they required. For example, you think about rock turret. How many steps? How much distance? This is something you need. Okay, you need to think about it. And then, when someone can kick a wrong kick can, okay, just kick it. Boom. Well, something different. Can should deduct his HP. Okay, so you need to think about what kind of input should be. But this is something very interesting. In the past, you write a function or write a math, write a function, you just input an integer, input a string, input a flow, some primitive type. But for programming, it's quite amazing. You can use fighter at, as an input parameter as well. We will show you the source code next. And at the result, you can give back the corner and return the value, whatever. Does it really able to hit it? You can return a boolean true false, so to tell the users of the program to do something. And you need to always design your behavior with the parameter required data and the return type. What kind of information need to tell the user when they call the function? Just return something. Okay. Now, for example, parameter return types is always in class objects. It's quite common. Object in, object out. Okay. You write more program. You say the parameter is a writer. Return also is a writer. Object in, object out. And in the case that you call the method in or for the new name is that in the past we will so-called function. But when we start object-oriented programming, you will have a rename its function will so-called method, not no longer function. We'll call method something very similar. The source code is similar, but the methodology behind the scenes is method will train the object, change the data inside the object, change the state of the object, but function is not called about that. In general, we will so-called pass by value. We will make a copy of the data of the reference in the object so that it's something difficult to understand here. But when you pass something in a function, in the past, a primitive type, it will not train outside the realm, but for object, it will train it. That's so. For the program here, we want to model the scenario to write a rock to it and then kick it. Okay, rock to it and then kick it. And you just write the program like that. You just walk towards 4 step. You need to tell it for 4 step. The 4 step. And then kick it. And then how to kick? Roll, kick can. It's just like an Angular, very straightforward. Since you involve two object together, otherwise you can't model this kind of scenario. Okay, here's the output. You just the source code here. You just simulate the fighting game with just test. Okay, repeat the name of the current fighter. Can can rock forward rock forward 4 step. It's like that. Can and then kick the operand. Okay, kick the operand. Can kick. Okay, roll kick can. The name operand name is can, and then the operand is can. Can deduct his energy, and then it move backward 2 steps. We are able to model the behavior of a single kick and rocking. In Python in general, you can use something like that, but we will solve it later. Here is without the type, but later you can do something like that. And For the center, we want to have more output to handle it. We just add additional line. Negative 0 becomes 0, positive is 100, and then we pin the energy all the time so that we can can HP become new value just for the ease. And okay, but here you have something to be careful. We normally will not use the encapsulated the private setting here for other field. This is for HP, so that we will use a private value of HP internal one. But for the name, we will generally we will always go through the getter. Yeah, if you call that, we'll go to the getter, not setter. Go to the getter to get it. Since in the later in the program or in the future, you may modify the getter to ensure the output format already consistent or already accepted. For example, uppercase, lowercase, remove the space. You are quite straightforward. Just every time you get the name, you just remove it. Oh, the programming flow is that you create something, create an object from a class, then you call a method roll kick can, and then we will something called logically we will call message send a message or send a data pass through rob to can here, so that they have the interaction between two objects. There's a two object they have interaction. Yeah, in the object-oriented methodology is that everything is an object, and then the object inside the virtual world, the memory, they will interact with each other to make it like a real world scenario, simulate a real world scenario to solve a problem. Here the problem is a game. Okay, for the remark, for parameter, okay, the data sent into the object parameter, your function called roll can. If it is the something primitive type, for example, integer, okay, integer or float, it will not train the value. For example, you train the integer inside a function, it will not train the value, the global one. Okay, you learn from previous classes, but you need to very serious behavior case. If it is not a integer, it's an object. For example, rope and can here. Okay, this source code is something you need to beware. Rope and can here is this is not the primitive type. This is not number floor. Okay, you train the data in can the object of represent can will is really changes. Not like something before you put input a integer 4, you inside the function you may have the here integer for step, you may change the value of step. You change the value of step does not mean it will change the input the global value of the step. This 4 will never change. You learn from Python programming the basics one. You will see the stack here. But for OOP, if you want to understand more, this is something called pass by value, but the value is reference. This is more complicated. But if you don't understand, don't worry. You just know the behavior. This kind of behavior, if the source code is two objects together, the object will be interactive together, and then it will train the data inside the object. For example, can energy will deduct. Okay. If you don't want to, you send an object with train. If you don't, you can also return something called tuple to multiple value instead of classes. You have your flexibility to design. Okay, you just learn the first object-oriented methodology. The first one, the complicated one, encapsulation, is very difficult word. And then we will continue to learn about the inheritance and abstraction and the polymorphism. It is not really very complicated, but the name is very difficult. Don't worry, just try to understand it in real world example. The main reason for us to using OOP is that we want to reduce or minimize the chance of the error. Encapsulation is something very important, since you hide the unnecessary detail and don't let the other user or other programmer touch it. Everyone just like driving a car. You just put the gas button, it move faster. Push the brake button, it stop. That's all. Don't care about it. Just use it. You call a program. You have the program generate QR code. You don't need to know about the mathematics behind the scene to generate QR code. Don't care about it. And And okay, the second benefit is that be smart lazy, and we would have other three logic to make it smart lazy. Inheritance is something very nice. You just get everything from your ancestral, your father, your grandfather. Your father have some have some ability. You got the ability from your father. Your grandfather have some ability. Your father got it. You also got your grandfather ability. It is very amazing logic. You will become very, very strong and powerful. Your program, since you're able to inherit and get the power from your previous ascension. We will reduce a lot of source code and then very easy to maintain since we just get the ability from your father, grandfather. And then we will have other two concepts to make smart lazy is abstraction and polymorphism. We will try to write a program able to evolve very easily, evolution. But don't worry, we just see the example, you will understand it. But the behind the scene is try to make your software able to evolution very quickly. And you will learn other topic in design pattern in the future or later. It's quite straightforward. You just on top of do object oriented pattern design, and then we have some design pattern to combine them together to solve some problem, general problem easily. Now our game become more and more attractive, more and more character. Well, we are Street Fighter, not Street Fighter anymore, not just two fighter. We are king of the fighter. We got many, many character. But in the case that even though there's a lot of fighter in the game, but they share a lot of common feature. For example, every fighter got a name, every fighter got a HP, got some rocking, punch, kick, whatever. And we have the observation, we need to think about something common. For example, someone, if something is common, they should own it. They had it. Oh, for example, oh, every fighter should have the name, have the HP, no difference from before. Something they should know it, know behavior. Everyone know to do it. For example, they can punch, they can kick, they can rock, they can drum, and then every character had the differences. You know some differences. You need to have you have to model your program to handle the minor differences. For example, they may have different heights, different width for the attack area. Someone is bigger, someone have long hand. Okay, and then everyone have some special attack technique. Okay, and then everyone did a classes. Every fighter, for example, oh, there's Terry. There is something rock, have the special technique his own. It's something different. We need to model something has the common and difference with minimal effort. That is the something very nice so-called inheritance. For this game, we got 100 fighter maybe. Okay, but for the cases that you just model something relations called is a. Okay, is a relationship. Ro Aro Gamma. Wow, very long name. Roga Sangara. I don't know how to talk about this. Is the game name. But you know that they have the, even though there's two fighters is not a different, but they share something very common. For example, everyone have name, have HP, some basic both active, some basic behavior. They can do it. They can punch, they can rock, they can kick. But something they is specialized. Okay, general and then specialized. They had their own special move, special attack. Okay, how can we model it? No difference. The same, just everything from test, jump, punch, rock, kick, no difference. But when we model the special rider, we can have just inheritance. Here, Oriyagama is a fighter. Okay, done. When you write this line, your this new fighter will able to rock, able to kick, able to jump, also have the HP and the name. But for the name, this is something specialized. Okay, specialized. Different people have different name. You need to override it. So you need to call the base class. So okay, this is so-called your parent class. Okay, parent, father. Okay, and then you got the name, and then also they have something special. Only he knows his special move. His special move. Two fighter got two special move. Okay, no difference. you see that we have two more new fighter, but you can kick it. They can kick each other, and then this is the output and also have special move. Okay, but we just ignore the here. We don't know. We don't care about hit it or not. Okay, it's quite straightforward if you're watching a lot of animes or cartoon or movie. You will say that something you can inherit from your father. If your father have know something, the son also got something. But we mean expect the inheritance abstraction. Quite straightforward. You know, Rome know how to kick. Is alright. Is it why it is able to kick? Why they can kick? Is quite straightforward because fighter. They are fighter. He is a fighter. Ron is a fighter. So he inherit, learn from his father. His father give his ability and all properties. Okay, have the HP, have the name, have the kick ability, so that they can kick each other. So it is since they are fighter, also can be kicked. Oh, that's all. You know, if you got 100 fighter here, you reduce your source code shorter than 100 times already, and then also highly scalable. You can train your source code from the base card, and everyone can have new behavior. So-called abstraction also here. This is abstraction. Abstraction mean that you're talking about fighter, but all the fighter is a general case. General case work. Special case also works. Some potential errors still exist. For example, the programmer may put the wrong name. Okay, the name is wrong. And it's not make sense. Do you think it makes sense to ask your programmer to write the name every time? Don't make sense. We can also use the encapsulation again to fix this problem. Quite easy, just like this. We move here, we move the constructor, and then set the default name here. We move the constructor parameter name parameter, and then we set the fighter name here. Okay, when your source code become like this, perfect. No more name error anymore. Encapsulation solve your problem. And potential error too. Yeah, you may have the fighter here, but does it make sense to happen with fighter vs Rome, fighter vs fighter? Oh, it's not make sense. Fighter is not something really be able to materialize, or so-called physically happen. Fighter vs fighter. Who is fighter? You don't want to have some illogical happen between the interconnect fighter vs fighter. You it's not make sense. You don't know what is it doing. We will have the idea so-called abstract classes. We have the solution too, is that we want to we don't want to let people to create a fighter object. And then fighter actually is not something be able to realize. There's no way to realization. This is not something real. This is a concept. It is an idea, is a concept. This is something abstract. So we have the idea so-called abstract class. This is quite easy. Abstract class, it means something. You can't make it become an object itself. It must become, it is just a concept or parent concept. Oh, now we just import something so-called ABC abstract class from Python, and then you mark the attribute here. When you mark the attribute here, you can't call the fighter something. You will send you an error. Fighter should not be realization. It will not become. It will not allowed to become an object. It's not making sense. Okay, for OOP concept, you learn that three of them. It's quite straightforward. Once you do the inheritance, then you get your ability from your parent. Okay, you got the attribute, you got your method, what they know to do, the field they have, what they can do. So if you want to be lazy and write the source code shorter and very more powerful, you just inherit from a powerful base classes. If your father is a very rich people, you don't need to care about your fighter very powerful. You become very powerful than him. Quite straightforward. Okay, you just learn three of the important concept: encapsulation, inheritance, and abstraction. One more. But before that, inheritance, you need to think about it. Oh, and first of all, you try to do something like for mathematical point of view is so-called common factor. If you have a game of normally if you are a programmer, you need to refactor your source code all the time. When I first time write the program may not be optimized because we found some repeat code, okay, repetition code, with duplicate. When you write your program start have something duplicate, you need to think about is it any common factor and sum the differences, minor differences. If you find your class or program have a lot of common duplicate code, you need to think about extract it out, refactor it. One of the refactor way is that create a base class and then extend it, then solve your problem. And also you need to think about the inheritance. For the inheritance, we can have infinite number of parent. For example, a human, Saya human, Sengoku, Mikata. This is Dragon Ball, but I don't know you know Chinese or not. The logic is that the Saya, the human, Saya is human. Okay, Super Saya. Saya is Sumpong. So Sengoku is Saya, and the Mikata is Saya. This is logic. You can inherit many number of inheritance. Okay, logically you can have infinite number of parents. Yeah, and for the latest emulator, so-called run for all, you got the ability from your previous one, got the ability one by one, and then you know all of their their supernatural superpower. You got all the superpower from your parent. Yeah. But for some cases, we don't want to stop people from realization. Yeah, for example, abstract class is very important. For example, you don't want to have Super Saiyan vs human. Not making sense. Super Saiyan, we have Super Saiyan. Who is Super Saiyan? Okay, this is not making sense for your program. So we are normally we will mark the abstract. And then we want to stop people from inheriting. For Python, this is not this way, but for other programming language, for example Java or something, you don't want people to to have the son. Okay, you want to finalize this. For example, the security reason or efficiency. Well, you too many inheritance will be very slow, and also for example, you don't want people to you got a keyboard. Okay, you got a keyboard, it's a base class model the keyboard. You don't want to inherit the keyboard, send the security problem. You don't want people to keylock your abstraction of your keyboard. The security issue, you don't allow people to inherit it. You need to think about it. Yeah. And also, if you want to have two kind of ability, so-called you have two kind of power. This is multiple inheritance. You got two parents, father and mother, and then you can combine the power, become more powerful. You can in a minute in cartoon or movies, so that the rampart and then the roof, the roofery, have the hybrid, and then the hybrid become the strongest creature in the world. You see some movies talking about this kind of story. This is real. If the hybrid really good, is it very powerful, got all the power. But for single inheritance is make things simple. We will explain the problem, not the problem. You need to have some mechanism to make sure it will not become crazy. Normally, you for Python the case, you are single inheritance. In some programming language also single inheritance. If you want to execute something like multiple inheritance, we have other method, design pattern or something to do something similar. Be careful. But why this kind of object have the problem? And just here is some explanation. For example, your father is using right hand for writing, yeah, and then your mother is a left hand. Well, for the son, is the son using writing the pen? Take the pen. Is it writing with the right hand or left hand? You don't know. This is something we don't want our programming language unclear, and we'll discuss more later. But for the logic is that one more reminder. Theta pass is the same as here have object. You don't need to write this one since everything is object. For programming language, all the object on the network, everything is object. So you can omit this part object here. Object has some inheritance. You got some field from object. For example, you got a string, you got a hash, you got equal, bigger than, less than. You can always compare object, but you need to implement it yourself. we will talk about more later, is talking about polymorphism and overriding. Yeah, but you do need to keep it in mind. Everything is object. If you don't write it, it is also an object. You got some ability and data from object. For multiple inheritance, do have some benefits. For example, we have a this Java example. You have a Canada class. Okay, you have a cork class. Then you can create a Canada cork simple by composing it. Is it good? Is it great? Um, you just bring it. It look good. But for the case that if you do uh need to have multiple inheritance, so-called multiple parent, you need to think about if there is two function similar. How which one will be called? Oh, you need to you have some logic or some idea which one will be called. You can take a look to the example, but I am not recommend you to use multiple inheritance all the time. You just mixing simple stupid. Simple is beautiful. Okay, and don't need to trace the logic. For the case that for Python, you can have this kind of very complicated problem. For example, A inherit B and C, and then D also inherit from B and C. And when you call this diamond, you call diamond 1, you go object for A, M will call the C. Yeah, you see that is you need to, when you're using inheritance, if you support multiple inheritance, you will got this problem. At the end, if C have defined M, then it's called C. If I class it with something in different situation with different behavior, this is something complicated we don't like. Oh, even worse. Wow, this one, if you got this kind of resolution, actually behind the scenes there is something called CV linearization to evaluate the order of priority which method will be called after the multiple inheritance. But it will is really necessary to make sure this so-called overrun. Overrun is like that. You see the animation, the Hero Academia overrun is you capture all the superpower from different people. Yeah. Oh, at the back end you become a monster. Your program is become a monster. So um if unless you have very strong reasons, don't always use multiple inheritance. Yeah. Okay, just finished some topic about multiple inheritance, and now we're talking about the last concept is a very complicated one, look like complicated one, actually it's not. Yeah, it's called a polymorphism. uh, if you about you need to have inheritance or something called in interface when we explain more later, but you need to have a subclass or something, and then you got the unique behavior of all such class, and then the superclass variable to hold the subclass. We consider the parent and then son, put it together, but we will trigger a behavior on the parent classes, but it will execute the son ability. Yeah, call like a parent, but it take the action from the son. Oh, maybe very abstract and very difficult to understand. Don't worry, take a look to the source code. You know the behavior is okay. And with this in implementation inheritance, interface inheritance, we need interface or inheritance subclasses to execute polymorphism. Okay, why we need this is the problem is that we have a super combo attack for all character, but some of the character do have the super combo very similar. For example, this so-called attack so-called 威精 and this is, if you see the fighting here, I just Google it quickly, and I should have the, yeah, GF. I just deleted the image. Okay, yeah, this is the attack. The attack here. Yeah, this is not this one. You will come to there. Yeah, you will go to there, and then a lot of a lot of punch kick and then the final attack. This is something called riding dragon attack. Oh, I am not sure if you go to game center to take a look. Yeah, you get just something like that. We want to model this one. Okay, but a lot of character, a lot of game character got this very similar attack like them. But they're very similar. Just the first move and then the final attack is different. Okay. We want to have the abstract method. First of all, why we want to have abstract method, not just class, is that we need to ensure all the fighter will have super combo. Okay, must have super combo. This is very useful. Every fighter must have super combo. But from the fighter point of view, how is the super combo? I don't know. Since it is a parent class, you don't know the actual implementation, actual super combo. How does it move? How does it do it? What they are doing? So you don't know, but you need to make sure your son or your parent, this is a parent, fighter parent, your son class, child classes will have super combo. You will have abstract method to ensure them to have super combo. Now, when you train your social here, then you run the program, you will find that, oh, everyone they will not able to run the program since the super combo is missing. They must have super combo. So we train our source code. We train our source code to set the super combo to the Yata Gayon or something. I don't know. And then this another fighter is another super combo. It work. It will be able to program. Okay, you will able to run the program. But now we do something funny is that we want to have an array, a list to put all the fighter together, and then use for loop to call the super combo. What will happen is the magic. Here you just treat it as a fighter. Don't care about is it Yogo Yo or Arrow, but you don't care. You just loop it and call super combo. It will behave something interesting. You from the parent cast call super combo it, but the final execution will be the individual trial super combo. The children super combo. This is the main idea polymorphism. You can just consider the parent. Use it like a parent, but it will have different behavior for the actual output. In the real world, all of the plug-in or it's writing in this style. If you have some plug-in, you learn about a lot of program. Firefox, you plug-in. Chrome, you plug-in. The plug-in is just like that. You define a base class and then make sure the plug-in, the extension implement the abstract classes, and then you got the extension extendability, and then the extension is use this kind of style to write it. Okay. Oh, we need to we are just doing something called method overriding. Riding means that you got a exactly same method name, same return type, same parameter as your parent. Super combo. Okay, same name, same input, same output, and then you just try to override your parent ability. If you think more clearly, this is a kind of evolution. Your parent give you something, but you want to have more powerful one. Here is the example of overriding. Since there is square and rectangle. Okay, square is a special kind of rectangle. There's a parent, the child, and then you get area is our overriding method here. This one is the overriding, and then you just call it. It's just directly to calculate for you. This is one of the example. And another is very similar. Don't misunderstand it. This is overloading. Overloading and overriding is very, very different. And then go to job interviews. It's quite common. My student go to interview Microsoft. Microsoft ask him this question. You need to make sure that overloading is another thing. Overloading will have different signature. For example, here is signature. First, no parameter, head parameter, none, integer number flow parameter and then stir parameter in string parameter. This is different. It is another thing. Nothing to do with inheritance, polymorphism, nothing to do with it's just something you got a function name, the same parameter is different, input output is different. This is something called overloading. And for example, here is something overloading. For example, this is a source code. If you want to Python overloading, you need to import the Python tools, and then you can overload with different input and output parameter. But you use it just follow the source code. If you need, you can design your program with overloading. It's okay, but in general, we don't care. So if you understand it, overloading and overriding is something totally different. Don't think they are similar. Yeah. And something called keyword-based arguments. For example here you got a stir none. If you got a stir here, you will set the first method. If this is not none, you pin it. If you got a stir here, the type is here, something you call string. But for you put a one, it will still work. This is something by the design of Python. Python typing in Python is something optional. It is not doing it's not care about when it is running the program. If you have this kind of program, your editor, your Visual Studio Code or PyCharm will show you an error. It is before the program run. It is just the IDE do the error for you. But for Python itself, it's always ignore all the typing information during the runtime. So be careful on this kind of problem. Yeah. Why you override your parent? It's quite straightforward. Since your parent may provide you some ability, but it's not strong and not suitable. For example, when you try to pin an object, pin something, yeah, you always pin something to debug. Yeah, quite straightforward. Pin something debug. If you pin here, you will pin something very ugly. This is the memory address in the RAM, in your RAM memory. Memory address is always useless for human. You don't want it. You want to pin the name. How can you pin the name of the writer? It's quite easy. Override the parent method. Stir. Here is the always doing. This is something we are always doing. Every time we writing Python program, this method will always override. For example, we just writer from the parent class on not to the child class. Just override cell.name and then cell.hp. Then you pin here. It will output you the name and the HP of the writer. It become the pin function become meaningful. And actually for the pin function is calling the object, the object class, the highest parent is called object, the object stir function, but we override the stir function, then we can pin something meaningful. Here is some basic method from Python. You will sometimes override. For example, if you do something need to have the order. You need to come. If you want to have the ordering first and second, you need to tell people what does it mean equal, what does it mean negative, hash function equal. You need to override one of them. Yeah, you need later you know it. Oh, here is this one is here, not that side. Yeah, you want to override, make use of the evolution. Since if you play the game before, you see the raging tiger attack is very similar for most of the character, since it's a common. But the last move is different. This one is a punch to the sky, the upper punch, but other is a broad, a different attack. Okay, but we want to have this observation. Oh, just the final attack is different. The first one is a sequence of punch and kick, but maybe difference, minor difference. Okay, and then but the basic last move is different. Suppose they have the similar punch and kick number and do something similar. We want to share the first part, but the last part I want to override. You will expect we will have more character in the future to be able to have different final move. How can we model it in Python? Yeah, this is difference. This is a so code get. Yeah, for this is the we have another parent card, abstract cards. Okay, fighter. After fighter, we have Dragon Tiger fighter. This is from the game Dragon Tiger, and then Dragon Tiger we have something to something basic move. Everyone know it. We got this the Racing Tiger, the Brogat, yeah, and then Dragon Range, and then the sequence, the basic sequence for everyone. Since you have the punch kick, but some people will kick more, some people will punch more, but this is some basic sequence. We just try to rewrite our program, have the abstract card, abstract one more abstract method, since everyone be able to have some ranging target technique. It is the common technique, but abstract, since everyone need to have difference, but everyone have some common part. Is the punch, a sequence of punch and kick. We just put a list here, array here, set it up, and then store it. And then the first part will be the use a for loop to represent, the first action here. The first action is, yeah, here the first action. Yeah, and then final action is different. Okay, everyone is ready to sim kick. And then for the implementation, the super combo, we will have this set up. We will have basic sequence. Set the basic sequence for everyone, and then we have the last kick. It's a super combo with the Raging Tiger, the non-volleyball. Okay, let's see the Robert. Robert is him. This one. The last is a 波動拳. This is so you can. Oh, let's model the Robert. Robert is that the final attack with just evolution method overriding, not loading, override. Overriding is it just calls a basic move. The basic move for him is simplified: punch, kick, and then punch. Okay, kick and then punch. Set it up when create robot. Set the last sequence: kick and then punch, and then the final move is a broad, broadcast, and just complete the implementation of robot. And the roll is different. Roll is not kick punch. Is first he will punch and then kick, but the final move is the upper punch, not the broader. Yeah, it's different. Done. We have the common setup. And then for the program, we quite straightforward. We add two more character. Okay, two more character here, and then put it into list, and then use a for loop. You see the output. We just execute the polymorphism with the base cast fighter, and then Tiger, Rising Tiger fighter, and then we got the polymorphism implementation for the super combo. This is the example of polymorphism, but if you understand the meaning behind the scene, it's make the software evolution much more easier. Okay. Now, oh great, you can add a new feature with the existing source code query quickly. By taking a look to the main, you take a look at inheritance and polymorphism. You don't need to think about the details of the combo. You will in the future we will have more character, but just create a new character and then put into the array, put into the list. Okay, yeah, just add more here. No difference. Your source code, you don't have to train anything. Now, okay, we have some more concept. It is a bit difficult, but sometimes you will see it. You will so-called class variable. Class variable is different from instance variable. What is class and instance? Instance, it means object. Okay, no different. Instance is the object, and the name of the OOP instance is just object. We will have two class variables. Something is in the class level. Something is in the instance level. What is the class level, instance level? And class level is shared by all objects. If you remember, class is a template. Template is only one. But the template can create a lot of objects or a lot of instances. Instance or object have their own memory, own variable. So this one is unique. This one is individual. Every student have their name and their roles. You can see that when you have this, you can stream is common here. Stream is common here, but you can see that there's different name, and this is the rate of reused classes. Sometimes it's quite normal. We must be careful. Is that people will use this as a counter to take care about how many objects they created. For example, ID incremental at 1, 2, 3, 4. But really be careful. Is that normally we will use database to solve this kind of problem. In the future, your program may be run in different server. Then the memory is different. It will not work. So don't always using that. If you're using that, you need to keep in mind your program is single thread. Okay, single thread, single computer within a one time, only one, no more. Yeah, okay, no, no, bound to the class, only one. But class method also bound to the class, not many, not the object. And you need to have some parameter and class. You will not able to touch. Remember, your class method is another class variable and class method. Class variable class methods to be shared, so you can touch it, and then you can see the example. Because for class variable and class method, and we will call it static method. Yeah, normally we call static method since the static method will be stick to the class level, not the object level or instance level. Only in the class. It is only one, not share. Um, you can access and modify the class state since the static method only in the class variable, but the created object have their own memory address. You can't ask the class to train it. It's a bit difficult, but take a look to the source code. Yeah, here is the final slide, and here is something called a person. We got a class method, and then we have some setup here, and this is you can touch it. The class method can touch it, um but you don't need to. You can here is adult. Okay, it's adult. Can you see person is adult? Person is adult. You just input an A here, and then it directly. You don't have to load or something. It is just a class. Okay, this is something the file one. It's class method. It's very simple static one. Okay. Oh, this is the end of the OOP topic.